Good morning. Today we are writing linear equations in standard form. This is the third and final form that we're learning. The only difference between standard form and the form y equals mx plus b, or slope-intercept form, is that our letters x and y are on the same side of the equal sign. Here, x is on one side and y is on the other. If we just move this term over to the other side, well then x and y are on the same side. The a, the b, and the c are all just numbers. So it could be like 2x plus 3y equals 10. Or some other random numbers. But they, when you take the NCA, they don't want any of a, b, and c to be fractions. So instead of having like 1/2 x plus 2y equals 6, we would need to multiply this equation by some number to get rid of that fraction. So that's what we're going to be doing down here. So if you think back to 6th grade or 7th grade, when you were taught equivalent fractions, 1/2 is the same as 5/10. The only difference is we just took that fraction and we multiplied it by 5. Because 1/2 is the same as 5/10, it's just written differently. Same thing, 5/10 is the same as, if I multiply by 2, 10/20. 10/20, these are all the same. They're all the same fraction. They're called equivalent fractions. Well, we're just going to find two equivalent equations in standard form that are equivalent to this equation. So I could multiply or divide. If I just want to take this whole equation and multiply by 2, I would get 5 times 2 is 10x. 10 times 2 is 20y, and 15 times 2 is 30. These are equivalent equations because they're exactly the same, just like the fractions were down here. But we need two equivalent equations. So this one I multiplied by 2. Well, what if I wanted to divide? If I divided everything, these are all divisible by 5, I could make this smaller. Just how I could make 10 over 20 smaller by dividing by 10. So if I divide by 5, I would get 5 divided by 5 is 1x, 10 divided by 5 is 2y, and 15 divided by 5 is 3. Now you can multiply or divide by any number that you want, as long as you have whole numbers here. Okay? So this one, I want you to multiply by whatever number you want. If you want to multiply by 3, we can multiply by 3. This is really a 1, so then we have negative 3x. 3 times 2 is 6y, and 3 times 9 is 27, but it's negative, so negative 27. But we need two equations, so now I need to pick another number. I'm going to pick 5. If you want to pick 2 every time, that's fine. 5 times negative 1 is negative 5. 5 times 2 is 10y, and 5 times 9 is 45. So these equations are equivalent to the first equation. But now we were just given standard form. We need to know how to work our way through all three forms. So it says write an equation in standard form that goes through the points. Well, if we just have 2 points, I can probably get to this form, point-slope form. But I need to find my slope. So I'm going to use my slope formula, y2 minus y1 over x2 minus x1, and plug it into my points. X, y, that's my first point. X, y, this is my second point. And let's plug it in. So y2 minus y1, we have 1 minus 7. And x2 minus x1, we have 5 minus 4. So 1 minus 7 gives us a negative 6. 5 minus 4 is 1. So 6 divided by 1 is still 6, but there's more negatives. So our slope is negative 6. And that's exactly what they have here in our point-slope form. They already plugged it in. And we can use either of our points. If we wanted to use this point, we would write y minus y1, which is 7. They already plugged that in, equals our slope, negative 6. And then x minus x1, which is 4. we could have used the first point for that one, or the second point. If they use the second point, x2 would go here as 5, y1 would go here, which is 1. Now, they showed you both of those already written out, but our goal is to try and get over here to standard form. Well, to get from this form to this form, we could go through y equals mx plus b, or slope-intercept form. All we have to do is solve for y to get y all by itself. So because this bottom equation, let me erase those lines there. Because I have space underneath this bottom equation, I'm just going to use this one. If you wanted to use the first equation, you can. You'll get the same answer. So if I distribute here, negative 6x, a negative times negative is a positive 30. And then get x by itself, add 1. So we have y equals negative 6x, and 30 plus 1 is 31. Well, that happens to be exactly what they have written here. These are just showing you that, yes, it is working. We solve for y, and we get slope-intercept form. But now we just need x and y on the same side of the equal sign. So all I have to do with this x is add it over to the other side. Because it's a negative, the opposite would be adding. So we have 6x. We can't combine these because one's an x and one's a y. Plus y equals 31. And that is our answer. X and y are on the same side. There you go. 6x plus y equals 31. If you want to put a 1 there, you can. We're going to practice this a few more times. This one says write an equation in standard form of the line that passes through the given point and has a slope m. You guys, this is the same. They're just already giving us our slope. So we're going to start with point-slope form because we have a point and a slope. And I'm going to plug it into my point-slope form. So y minus y1, which is a negative 1, that makes a positive. Our slope is 3. And then x minus x1, which is 4. Our goal is to get to standard form, so we need to get rid of these parentheses. We need to distribute 3x. 3 times negative 4 is negative 12. And then we want to get y by itself first. So I'm going to subtract 1. So we have y equals 3x. And these are all negatives. Same sign, adding, keep. That's a negative 13. And then last, we want to get x and y on the same side for standard form. So I need to move this over to the other side. I'm going to subtract 3x. We have negative 3x plus y equals negative 13. This is in standard form, so we are done. If you want to put a 1 there, you can. I would like for you to try the second one and see what you get. I'm going to plug in my point and my slope into point-slope form. So it would be y minus y1, which is negative 4. That makes a positive. 2 negatives makes a positive. My slope is 1/2. And then x minus x1, which is a negative 15. Again, 2 negatives there make a positive. So let's distribute, get rid of those parentheses. 1/2 times x is 1/2 x. Half of 15, that's not going to be a nice number. Well, half of 14 is 7, so half of 15 would be 7.5, or 7.5. And then get rid of this 4 to get the y all by itself. Subtract 4. And 7.5 minus 4, well, 7 minus 4 is 3, and we have the 0.5 left over. It's still positive. So that's y equals mx plus b, or standard form. But we want x and y on the same side, so I'm going to subtract the 1/2 x over to b on the other side. So we have a negative 1/2 x plus y equals 3.5. Now technically this is a correct answer, But the reason why back here we learned how to find equivalent equations is to get rid of those fractions. If we ever have a fraction, like 1/2, we can multiply by 2 to get rid of the denominator. If it's a multiple of 3, or a denominator of 3, we would multiply by 3. If it was a denominator of 5, we would multiply our equation by 5. So this one, our denominator, or fraction, is a 2. So if we just multiply by this by 2, our fractions and decimals should go away. 1/2 2 times would give us just 1, so it's negative 1x. 1 times 2 is 2, and 3.5 times 2 is 7. So this would be the best answer that your answer key would give, and that would be on the NCA. This is technically correct. I would accept this on a test, but we just don't want the fractions or decimals. These next two are exactly the same as what we did right here. We have 2 points. We need to take it through all 3 steps. We're just going to do so without all of the structure. So first I'm going to find my slope, y2 minus y1, over x2 minus x1. So xy first point, second point, and plug it in. y2 minus y1, we have negative 3 minus a negative 1, those make a positive. And then x2 minus x1 is 2 minus 3. So negative 3 plus 1, there's more negatives, it's negative 2. 2 minus 3 is negative 1. So 2 negatives we know make a positive when you multiply or divide. 2 divided by 1 is just 2. So I'm going to take one of my points, I'm just going to use the first one, and my slope, m, and plug it into point slope form. Start with what you know. I know I have a point and a slope, so I'm just going to use point slope form. So y minus y1, which is a negative 1, that makes a positive. Our slope is 2, and then x minus x1, which is 3. So let's distribute to get rid of the parentheses here. 2 times x is 2x. 2 times negative 3 is negative 6. And we want y by itself, so I'm going to subtract the 1. So we have y equals 2x, and these are all negatives, so minus 7. But they asked us for standard form, so we need to move to get x and y on the same side. So I'm going to subtract 2x. It's positive, so that's why we subtracted it. So we have negative 2x plus y equals a negative 7. Don't forget that negative. That would be your best answer. Since we've done 2 like this already, I would like for you to try this one, and then click play to see if you got the answer right. So first I'm going to find my slope, y2 minus y1, negative 5 minus 6. And on the bottom, x2 minus x1, or negative 12 minus 10. Well, negative 5 and a negative 6, they're all negatives. So that's negative 11. And negative 12 minus 10, those are all negatives as well. That's negative 22. Well, I know 2 negatives make a positive. So 11 over 22, I can divide by 11 to simplify. And that will give us 1 over 2, or 1/2. Some of you are getting confused and saying 2. It's not 2. It would be 2 if the 22 is on the top, but it's 1 over 2. So I'm going to use my point slope form because I have a point and a slope. Same equation that's over here. So y minus y1, which is 6, equal to our slope, which is 1/2, and then x minus x1, which is 10. So let's distribute to get rid of this. 1/2 times x is just 1/2 x. Half of negative 10, well, half of 10 is 5. You can also plug it in your calculator. And then last, add 6. So we get y equals 1/2 x. And there's more positives. 6 minus 5 is 1. So like I said, this would be an acceptable answer, but we don't want fraction. So in order to get rid of this fraction, we're going to multiply by the denominator, which is 2. Oh, oopsies, hold on. We messed one thing up. We didn't even get this in standard form yet. They want x and y on the same side. So first, I need to move my 1/2 over to the other side. So we have a negative 1/2 x plus y equals 1. And then now we can multiply by 2. Sometimes in the book they'll multiply by a -2 because they don't want the first number negative, but it really doesn't matter. It's the same thing as long as it's equivalent. So 2 times 1/2, 1/2 2 times would be 1x, and it's negative. Y times 2 is 2y, and 1 times 2 is 2. So that's our best answer. Moving along, these first 3 at the top, we are just identifying the form of the equation. So this one here with x and y on the same side, we call that standard form. The one in the middle, y minus y1 equals our slope, and then x minus x1. This is what we call our point, x and y, and our slope. We call this point-slope form. And then last, the form y equals mx plus b. That's not what it's called, that's what the letters are, but this is called slope-intercept form because we have a slope and a y-intercept. Slope-intercept form. Alright, we're going to do one more like we've been doing. It's just with a picture instead. Our goal is to get into standard form. First, we're going to find the slope. Then write an equation in point-slope form. Point-slope form, just a reminder, where we have our point and our slope. Ooh. And then we're going to solve to get into slope-intercept form, which we've been doing. And then move to get x and y on the same side. So our slope first, rise over run. If you start here, we're rising 1, 2, 3. And we're going to the left, which is -1. If you started here, we went -1, 2, 3. And over 1. Either way, these both equal just a -3. 3 divided by 1 is 3, and it's negative. So it doesn't matter where you start. And for point-slope form, we need a point. I'm going to use this point because they're both 1. Makes it easy. So y minus y1, which is 1, equals our slope, which is -3. And then x minus x1, which is also 1. So let's distribute to get slope-intercept form. That gives us -3x. -3 times -1 makes a +3. And then get y by itself, so the opposite of subtracting 1 is adding 1. So we have y equals -3x plus 4. And then our last step, we want x and y on the same side. So I need to move this 3x over. It's negative, so I'm going to add 3x. So we have 3x plus y equals 4. There's an equation of this line in standard form. Alright, our next two. These ones are actually a lot simpler than you think. It says write equations of the horizontal and the vertical lines that pass through this point. So first, if we just plot this point, x and y, here's x, here's y. X is first a -3, so -1, 2, 3. Y is -4, right there. We can write equations of the lines that are horizontal and vertical. So first, if I look at the horizontal line that goes through that point, that line right there, this line, if we think of what we taught before, it's crossing the y-axis at the number -1, -2, -3, -4. So it's the horizontal line, the equation of this line, it's crossing the y-axis at -4. if we were to make a table and plot points, those points would be plotted in a horizontal line. Because no matter what you plug in for x, y is always -4. If I say x is 3, 1, 2, 3, y is always -4. If I say x is 5, y is always -4, and so on. So it doesn't matter if you were to make a table. I just know that, hey, we learned previously that this means we're going to cross the y-axis at -4. So I plotted for us our vertical line now, and this is crossing our x-axis. So I'm going to draw, it's crossing our x-axis at -1, -2, -3. So this one, our vertical line, is crossing through this x-axis line at -3. We could have done this without even drawing our graph, because look here, x is at -3 always, and y is always at -4. So this one, I don't even need to plot my points. I know it's going to cross my x-axis. If it's crossing my x-axis, that line is going up and down. That's a vertical line at 5. And I know it's crossing my y-axis at -5, because a horizontal line would have to go through this y-axis. If you did want to plot the point, x is 5 to the right, y is down 5. The horizontal line, yes, it does in fact cross the y-axis at -5. And then the vertical line does in fact cross the x-axis at a +5. So there are a couple questions like that on your homework. Our last problem. It says, you are making 24 pounds of your own potting soil mix of sphagnum peat moss and coarse sand. You buy the peat moss in bags that weigh approximately 2 pounds. So we know just from that information, we have 24 pounds total of soil, and there are two parts, part peat moss and part sand. But we only know that the moss comes in 2-pound bags. So it says the last time you made potting soil, we used 9 bags of peat moss and 4 bags of coarse sand. Use this information to find the number of pounds in a bag of coarse sand. Because we know the amount for moss, we need to figure out, well, how much does the sand weigh? And we can figure that out because we have every other piece of information that we need. I don't know what. Whoopsies. So we know total of 24 pounds. And I'm going to say here that the peat moss is represented by X and the sand is represented by Y. So we have peat moss, and we got 9 bags of peat moss that each weighed 2 pounds. So 9 times 2 for each 2 pounds. Plus the coarse sand, and we bought 4 bags of coarse sand that each weighed, we don't know. We don't know how much the sand weighs out, so we're trying to figure out. So I'm going to use the letter Y to represent the number of pounds that are going to be in the coarse sand bags. So we can actually solve this because we have all the information except for how much the one bag weighs. So we know 9 times 2 is 18, plus 4y equals 24. So if we solve this, I'm going to subtract my 18, just my number. And I'm going to rewrite this up here. Those are eliminated. We have 4y. And then 24 minus 18 should give me 6. And then I just need to divide by 4. 6 divided by 4, and my calculator would give me about 1.5. So we know y is 1.5. This is how much one bag of sand weighs. So now it says, write an equation in standard form that models the possible combinations of peat moss and sand you can use. Well, we know our total is still 24. We have to have some combination of peat moss and sand added together. Well, we know they weigh 24 pounds total, and the bags of moss weigh 2 pounds, so 2 times the number of bags of the moss, plus we just figured out the the sand, y, weighs about 1.5 pounds. So the number of pounds for x plus the number of pounds for each y will give us a total of 24. And this is in standard form because this plus this should give us our total. And now it says list 3 possible combinations of whole bags of peat moss and coarse sand you can use. There is one in your homework where you actually have to graph this. And 3 combinations, we've done this before, where we're looking for 3 spots on the graph that we can find to list as a combination. For example, they gave us one combination already. They said we could use 9 bags of one and 4 bags of the other. So I'm just going to list that. X is 9 and y is 4, because we said x was the moss, which is here, 9, and y was the sand, which is 4. So this is one combination. So this would be like at the number 9, let's say these go by 3s, 3, 6, 9. We were up at 4, 0, 1, 2, 3, 4. That was one combination that got us to the 24. We also learned how to find both endpoints. We call these our x-intercept and our y-intercept of the graph. So if you think back to chapter 4, we found our x-intercept by plugging in when y is 0, because y would be 0 right here when we're crossing the x-axis. And our y-intercept was when x is 0. Right here when x is 0, that's where we're going to be at y, where we're crossing the y-axis. So let's plug those into this equation. First I'm going to plug in when y is 0. So 2x plus 1.5 times 0 is just 0, so I don't need to type that in, equal to 24. So all I have to do is divide by 2. 24 divided by 2 is 12. So this combination xy, x is 12 and y is 0. So that would be this point right here, 12, 0. We have 12 bags of moss and 0 bags of sand. And then last, plugging in when x is 0. So 2 times 0 is just 0. So we just have 1.5y equals 24. So if I divide by 1.5, y equals, and I don't know this one off the top of my head, I would have to plug it in my calculator, but it should give me 16. So this combination, x and y, x is 0 and y is 16, which makes sense. 0, 16 would be right here. Now I only showed you this on a graph because there is one problem on your homework where you do need to actually graph it to find 3 combinations. Because I could plot this point and this point to draw my line to find other combinations as well. We just did so without using a graph. So, like I said on your homework, there is one, oh, look, we did one just like this. There is one that you need to graph, draw your lines, and find 3 combinations right here. List 3 combinations. Good luck!